This video is going to be on solving the two-word problems in our study guide that we had for Unit 2. So this one is a distance equals rate times time problem, and so we're going to read it through. On the first part of a 317-mile trip, a person averaged 58 miles an hour. He averaged only 52 miles an hour on the last part of the trip because of an increased volume of traffic. The total time of the trip was 5 hours and 45 minutes. Find the amount of time at each of the two speeds. And so what we're going to do is we're going to draw a picture. So first picture that I'm going to draw here is I'm going to see that he is going to start at a certain spot, then he's driving a certain distance at 58 miles an hour. Then he goes for another part of the trip, which is his return trip home. But his return trip, or on the last part of the trip, excuse me, is 52 miles an hour. But his total distance that he went is 317 miles. And our goal is to figure out how much time he took at each speed. So we're going to define our variable. We're going to say let t be the time of the first trip, of the first part, excuse me. Then in class we set up these charts that should help us. So part 1 and part 2, and this is distance, rate, and time, because we know that the distance equals rate times time. So these two get multiplied by each other. And so the time, we don't know it, but we know that t stands for the part of the first trip. And then if you think about it, say the first part takes 2 hours. Then how many hours did the second part take? Well, I would take away 2 hours from the total time, which is 5 hours and 45 minutes, and that would be 3 hours and 45 minutes. But we want to write that as a decimal. So what we would want to do is we want to do 5 hours, and then 45 minutes is 3/4 of an hour. So 5.75 minus t would be the time of the second part, because if the first part takes 4 hours, then the second part will be 5.75 minus 4, meaning an hour and 45 minutes left over. So we don't know what it's going to be, but that's the way we would set it up. Then we know the rates. The rate of the first part is 58 miles an hour. The rate of the second part is 52 miles an hour. And we'd write the distance as rate times time, 58t, and then 52 times 5.75 minus t. And there's our two distances for each part. Now, as you can see in the picture, you have the first distance plus the second distance should add up to 317. So your equation would be as follows: 58t plus 52 and then 5.75 minus t equals 317. And that's how we want to set up the equation. So if you have a calculator, you're going to do 52 times 5.75, enter, that's 299. So we have 58t plus 299 minus 52t equals 317. Combine like terms, that'd be, nope, it'd be 6t plus 299 equals 317. And then we would subtract 299 from both sides. And so 6t equals 18, and t equals 3 hours. And so the first part of the trip took 3 hours. To find the second part of the trip, we would subtract it from 5.75. So that'd be 2 hours and 2.75, so 2 hours and 45 minutes. So first part, we would say in a sentence, of course, but I'm running out of room. First part took 3 hours. Second part took 2 hours and 45 minutes. All right, and so if you set up the chart for distance equals rate times time, I think you'll find it pretty helpful. All right, let's take a look at the other problem in your your what's it called, in your study guide. And so you've got this store that's dealing with all kinds of good stuff. And so it's dealing with televisions, and the store has 30,000 of inventory invested in that 13-inch and 19-inch color televisions. The profit on a 13-inch set is 22%, and the profit on a 19-inch set is 40%. The profit for the entire stock is 35%. How much was invested in each type of television? So first off, notice that you are trying to find two different things. You're trying to find how much was invested in the 13-inch and the 19-inch. So you really can't draw a picture for this. If you want, you can. I mean, you can make a television like that. Oh, class is out, but I'm still making a video. So there's the first television, 13 inches. And then you've got the other television. I know TVs don't look like this anymore, but with 19 inches, okay? And so then you can say let X be the money invested in the 13-inch TVs, and then let Y be the money invested in the 19-inch TVs. Okay, and so then you can create two equations. If you have two variables, you're going to create two equations. So the first equation is going to deal with just total inventory. So it would be X plus Y equals 30,000. And then the second equation will deal with just strictly profit. So if on the 13-inch TV you make 22% profit, that would be 0.22x. So whatever I invest, I'll get 22% of that back. Plus, the 19-inch is 40%. So whatever I invest, I'll get 40% back. So we multiply that by 0.4 equals, and then it says on the entire stock is 35%. So I'm hoping that I will get 35% of 30,000 back when I sell everything. So 0.35 times 30,000. And so if you have a calculator, you're going to do 0.35 times 30,000. And so that would give you 10,500 is what I got. And so now we can get a variable by itself in the first equation, substitute it in, and solve. So I'm going to subtract x, and that would get me y equals 30,000 minus x. Then I'm going to take this, and I'm going to substitute it in for y right there. So I'd have 0.22x plus 0.4 parentheses, and I'm going to plug in what y equals now. So 30,000 minus x, and then that equals 10,500. And so I'm going to distribute, so it'll be 0.22x plus, and if you have a calculator, 30,000 times 0.4 equals 12,000 minus 0.4x equals 10,500. We're going to combine like terms, so that would be negative 0.18x equals, and I'm going to subtract 12,000 over, and that would be negative 1,500, and we're going to divide by negative 0.18, and you would have yourself your answer for how much you invested in the 13-inch TV. So divided by 0.8, you get, I've got that the amount invested is $8,333.33. And if I want to figure out how much I invested in the 19-inch TV, I'm going to do y would equal 30,000 minus 8,333.33, and so y would equal and I've got $21,667 0.67 cents. And so for the 19-inch TVs, we've invested $21,667.67, and for the 13-inch TVs, we invested $8,333.33. All right, have a great day.